So to just kind of show you where to get started with this. So the first thing is, I saw it on almost all of your papers, but make sure you're drawing kind of this number line chart thing. And the reason for that is, it's the only kind of, well, foolproof isn't the right word, but it's the best way to really visualize where everything is. And that's going to help you with figuring out D, which is an easy mistake to make. It's also going to help you with figuring out the directions and the signs, which is another easy mistake to make. So by drawing the diagram, it'll help you figure out what forces you need. It'll also help you figure out directions and distances and that sorts of thing. So once I've drawn this, and again, I went ahead and labeled all the forces on here. You wouldn't necessarily have to do that. I find it helpful for me. When I solved this, I solved it at home, and I neglected to bring all my 13,000 colors with me. Normally what I do is I solve every force in a different color, and then I do all the forces added up in a color. This is just me. Again, you don't have to color coordinate it, but if you find that helpful, that's just a suggestion. I'll have colored pencils and stuff like that when we do the quiz, twist, whatever you want to call it. So that is an option if you want it. But here's basically what you're doing. You're trying to find for each of these charges, Q1, Q2, Q3, Q4. For each of these, what you're trying to do is you're trying to figure out what are the forces acting on it. And so the easy way to do that is to say, okay, if I want to find the force on Q1, it's acted on by all the others. So what are all the other charges? 2, 3, and 4. So there's a force between 1 and 2, 1 and 3, 1 and 4. Okay, let's say we're trying to do Q3. Okay, Q3, there's my charge. What are the forces? Well, it's going to be a force from 1, from 2, from 4. So here's my Q3, 1 and 3, 2 and 3, 3 and 4. So that's how you go about finding what this is. But then you need to find these actual values. Okay, you need to find these numbers. And the way you do that is by using Coulomb's law. So Coulomb's law is F equals K Q1 Q2 over D squared. So K is this value here, 9 times 10 to the 9th. It's always that value. Q1 and Q2 are your two charges. So this would be charge 1, charge 2. This would be charge 1, charge 3. This would be charge 1, charge 4. And then D squared is how far apart they are from each other. Now this one is kind of tricky because it starts at negative 0.02. On tests and stuff like that, I'll start them at 0 just so the distance is at least not as tricky as it's going to be already. Okay? So then what I'm going to do is I'm going to plug those in and I'm going to solve. So find the force between 1 and 2. K equals Q1, which is my first charge, which is Q1, times Q2, which is my second charge, which it happens to be Q2, divided by how far apart they are between them squared. Let's look instead at the force between 1 and 3. So for the force between 1 and 3, we have K. Q1 is charge 1, which is this one up here. Q2 is charge 3, which is this one up here. And notice I did not plug in the negative. It's not a negative 2.4. In fact, I never plugged in any of the negatives. There's no negative 2 here. That's not negative 3, not negative 9, no negative 6. I'm not plugging in any negatives here with any of these values. I'm just plugging in the numbers. And so the reason for that is because these are just charges, right? It's a negative charge. This is a negative charge. This is a positive charge. They're not directions. If you plug it into the equation, your calculator will think it's a direction. And that's going to give you the wrong answer. So make sure you're not plugging in negatives there. I've had people ask, what about the negatives in the powers? Those are fine because that's scientific notation. Okay? So to find the force between 1 and 3, I plug in my charge 1 value. I plug in my charge 3 value without the sign. And I find the distance between them. So if this is at negative 0.02, to get to 0.06, I have to go 0.08 meters to go between them. Think of it like a number line. Sometimes that helps people. And that's where I get the distance of 0.08 from. Okay, and that solved gives me 10.125. I'm going to do that for all of the forces. There's a force between 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4. And I just did that for all of them. I did it first. You certainly don't have to do it first. You can just do them as you need them. But I went ahead and did it first. And the reason for that was I already knew which ones I was going to need, so I just solved them all so I had them. So let's get to the hardest part, the part that people make the most mistakes on, which is this part. Okay? So the way you do this part, and I'll skip charge 1 because charge 1 just happens to be an easy one. And let's look at charge 3. So the way I go about finding the force on charge 3 is I start by saying what forces do I need to add? The force between 1 and 3, 2 and 3, 3 and 4. I don't need to add the force between 2 and 4 because that doesn't act on 3. It acts on 2 and 4. Okay? If I want to know how hard it hurts to get punched in the face, I don't care about 2 other people punching themselves in the face. I just care about my face. Okay? So I found the force between 1 and 3 already. It was 10.125. So now I got to figure out the direction. And the way I go about figuring out the direction here is I ask myself, I say, self, what direction will charge 3 move because of charge 1? So charge 3 is negative. Charge 1 is positive. Opposites attract. So charge 3 wants to go towards charge 2. And what direction is that? That is to the left. Charge 1. So charge 3 has to go towards charge 1, which is left. That means it's a negative 10.125. Now, it wasn't the first time I used it. And that's because the first time I used it on charge 1. And charge 1 is positive, charge 3 is negative. Charge 1 will go right to get closer to charge 3. Okay? And so that's why this time it was positive, but this time it was negative. That's an easy kind of mistake to make, and it's one I want to point out so you can be careful on it. Okay? So then I found the force between 2 and 3. That value was 36. And then I said to myself, okay, what direction will Q3 move because of Q2? So Q2 is negative, Q3 is negative. Opposites or like charges repel. So Q3 will go away from 2, so it has to go to the right to get away from 2. That's why I get a positive value for the 36. And then lastly, I need to find the force between 1 and 4. I found that value down here, 2.16. Okay? And 4 is negative, 3 is negative. What direction will 3 go because of 4? They're like charges, so they repel. So it gets repelled away to the left. Okay? And that's why that value is negative. So, negative 10, positive 36, negative 216. I end up with negative 190.125. Yep. Don't get what? Okay, so imagine that you are bossing someone around. This sounds right up your alley, Avery. So let's say you're picking on someone, and you and 3 of your friends are all pushing someone. Okay, and so you're pushing to the right. The friend A is pushing to the left, and another one of your friends is also pushing to the left. If I said to you, what direction are they going, how would you figure it out? You would add all the forces to the right, and you would subtract all the forces to the left. And the way you figure out the direction is based off of who's pushing which way. Right? With me so far? Okay. So you're trying to figure out, like if I want to push this and I have a bunch of people pushing, I figure out what direction are they pushing first, and then I add all the numbers together. Okay? That's what I'm doing here. What I said to myself is I'm looking at charge 3. So when I'm doing that, focus only on charge 3. What way will a negative charge go because of a positive? Well, it'll attract towards it. So then you say to yourself, what direction is that? That's left. Left is negative. That's where the negative came from. So I made it negative because Q1 pulls it left to get closer. And that's why I made it negative. It's not automatically negative because this is negative. It's not automatically negative because this is on the left. It's negative because to get towards 1, it has to go left, and that's negative. Okay? So then for the next one, I said, okay, 2 and 3. Which way will 3 go? It's repelled. They're like charges. Which way will 3 go to get away from 2? Well, it goes to the right to get away from 2. That's why I made that value positive, because it'll go to the right to get away from that one. Okay? And then lastly, we get charge 4, negative and negative. What direction will this go to get away from 4? Well, it has to go to the left to get away from 4, and hence why I made that negative. So you're always asking yourself, what direction does the charge need to go to get towards or away from whatever charge you're looking at? Does that help a little bit? Yeah. Okay. So it's based off of the direction the charge will move. Something that helps some people sometimes is to think of it like only your charge that you're looking at can move, and the other ones can't. That's not exactly true, but when you're solving, it works that way. So say to yourself, okay, only charge 3 can move. Which way will it move because of 4? Well, it has to get away from 4. Which direction is away? Well, if 4 is on the right and 3 is on the left, away is to the left. So you're always thinking about what direction will it go, and then ask yourself, is that positive or negative direction? And then you add the things up. Something that can help is once you've used the charge once, once you use the force once, the next time you use it, it will be the opposite sign. So the first time I used 405, the second time I used it, it was negative 405. Okay? The first time I used the 36, it was negative 36. The second time I used it, it was positive 36. So, and that's Newton's third law. Every action has an equal and opposite reaction. So the first time you use it, you can check your direction because the second time should be the opposite direction for it. Okay? Any other big questions I can answer? All right, I'm going to make one more quick loop around. If you're done with practice 1, go ahead and submit it to the practice. Okay? If you're not done with practice 1, try to do some of it on your own now. Okay? Try to do some of it on your own now. You don't have to get finished. You're probably not going to get finished. But try to do a little bit of it now so that you can make sure you know what you're doing when you're solving.